Although I sold my previous sorcerer, I happened to find this one here recently, local to me about 6 miles away. And during that time, I went ahead and picked it up. Now, this sorcerer, as I show here, is in pretty good condition, except there was one major problem. And that is this. So this is the System 9 MPU board. And you may see in this general area a lot of damage. And if that does not look very well there, you'll see more of that as I turn it over. And yeah, this board is quite corroded. Probably one of the worst corroded boards I've seen in a while. In fact, the PCB substrate is so bad, if you push on the board, it'll start to crack where it's been compromised. So, what am I going to do? Well, I do what any other person does when they work on machines. They buy every System 9 board in the Midwest. So what we'll be doing today, walking through some of these boards to fix them, showing some key things, like using Leon's test ROM and some bench work on how I go by repairing these boards, and hopefully we'll get one working that'll go back into the sorcerer. That's what we're going to work on today on Pinball Workshop. Stick around. So we've been talking about these System 9 boards, and what I like to do is talk about fixing these boards to make them whole again. So the one thing that we need to do first, whenever looking at any of these boards, is to first talk about kind of the state that you're finding these boards in. So I showed earlier, there is this board that I bought in that sorcerer machine that had all the corrosion. This is not a board worth saving. It could be used for parts, but in terms of using it and trying to clean this up, it's just well too far gone. You can see the entire solenoid selection, or the solenoid, the AC relay, all the way up to this 65, this PIA, and then down all the way over to these capacitors. This entire side of the board is just completely gone. In fact, I thought this was interesting. Just a quick note. When I pull the board out of the sorcerer, you can see the corrosion actually made it all the way to the backplate and all the way into, let's see here, hard to tell. Oh, not that one. Yeah, here we go. All the way into the connector itself. So this board, not worth saving, but I bought all these other boards that I want to walk through. So I've actually fixed a couple of them already, and I want to walk through what I did and what's important to look at for fixing these. So let's start right here. So this is going to be board number 1. This board I purchased from a good friend in the Cleveland area, and the first thing that I wanted to do is visually inspect the board. There's a couple things on these System 9 boards that are key things to look at and things that I found when looking. So you obviously want to first to make sure you have your two 6802s or 6808s, which I do have those here. You also want to look to see if you have all your PIAs, they've been populated appropriately. You're also then starting to look for any damage, physical damage, or other rework that's been done. In this case, you can see that this transistor is a little wonky looking. And then you can also see that it looks like someone has really just bent all these connectors. They've broken them off. So it looks like someone just yanked this board out and went from there. Let me just turn this board around. The last thing that we want to look at is we want to look at not only this capacitor, C9. You want to make sure that it looks like it's in good shape, but also the other capacitors that are found. And you'll see, if this will focus, see how these are bulging underneath? So these are something that I want to go ahead and change out. And you see this over here as well. Those are not supposed to be bulging like that. And this is telling me that these capacitors do need to be changed out before I put this board into service. We talked about corrosion. The great thing about this board is there's absolutely no corrosion. Great to have. Let's turn this board over and let's see if we see any rework that's been done. So there's nothing wrong with rework as long as it's been completed successfully, and it's been completed, with what looks like to be the appropriate methods and means. So as I look over this board, I don't see a lot of rework, which is actually really good to see. Looks like this board has relatively stayed, rework free. There are a couple of, let's see if I see that. There's a transistor here that's been replaced. But all in all, this board is good, ready to go. Now, the last thing I like to look at are these resistor packs. So these resistor packs are nothing more than just a regular carbon resistor, but they're in a pack of 4 to 8 or 10 or how many there you'll see. And you're just looking for any ones that look burned up. Now you can test these with a digital multimeter, but in this case, I'm not seeing any that look burned. So again, another great thing to look at. Finally, we're going to look here over at our lamps, and you can see that definitely some heat damage. You can also see from this connector. Again, this is nothing to worry about initially on the board fire up, but I'm not seeing anything here with any, any major issues or, again, any rework that's been done that looks out of control. So all in all, I'm ready to hook this board up, and let's see if I can get this board to test on my bench power supply. Now, I haven't covered this in a video, but I took a regular power supply unit from an old computer and made this nice bench power supply. I'll be doing a tech and tools video on this here soon. Just don't put your finger in that hole, because that's the hole of death. But what we want to do here is first hook up this board and make sure that we can use it and test it appropriately. So what we want to look for is one J17, which is going to be near your battery compartment. And you're going to see where, if you have the board oriented the same way I do, is you're going to have 3 pins, and then 2 pins. And then there's 3 pins for ground, 3 pins for plus 5 volts, 1 pin for negative 12 volts VDC, and 1 pin for positive 12 volts VDC. And what I'll do is just use my alligator clips appropriately. And I see that I've got my ground wire going back to my ground. I'll take my 5 volts, which is my yellow. I'm going to push that on any of the pins. I usually just choose the first pin, but it does not matter as long as you make sure that you get the pin on 4, 5, or 6. They're all connected, so you just need to get one in here. I've got negative 12 volts going here to my green, and then positive 12 volts VDC going to the red. Now, I've got this board ready for bench testing. Now, there's a couple key things here with this current setup that we're not going to be able to test. We're not going to be able to test our lamp, our lamps. We're not going to be able to test our solenoids, because those power are going to come in maybe from different directions or different connectors over here that we're not powering these. But what we're looking for is to see if the MPU board will boot appropriately. Now, how do we know that? If we look at this LED right here, it's going to tell us how the board is going to boot. And if you see anything other than a 0, that means there's a problem. So in order to test that, let's go ahead and let's switch our on button. We heard the relay click over here. That's a great sign. And then we can see that we've got a 0 on the board. So this board's, although bought untested, it looks like the board will at least power on. So this is great for us. That means that if there's other issues in the board with maybe the lamps or the solenoids, I can take care of that at a later pace. But this tells us that the board at this point can boot. So this is great. Let's go ahead and pull another board over, and let's see if we can figure out what's going on with it. All right, so don't let your eyes fool you, but this is board number 2. I went ahead and hooked it back up because I want to show you some key things that are different. First, let's again do our physical inspection. So the one thing we notice real quickly is that this board has no ROMs. We can see this here that are admittedly so. We can also see that we have a jumper here of W12. Now, one thing that's important here about these different jumpers, I'm going to put a list of the jumper settings right here. But those jumper settings are going to tell us some key things.
Not only can it tell us about our IRQ circuit in terms of how it's going to be running, but also in this case, this dump jumper means that instead of using 2 ROMs to run the program, we're just going to use the 1. So it's important to note that if you start burning ROMs, always to take a look at your jumper ratings and see what they are. But one thing that if you looked at this board already, you'll see a very key difference is that there's a lot of sockets. Socket. What that means is this board's had a lot of rework done to it. And in fact, I've done some of this rework already. This board was something that I got working on. 12 hours went by of me banging my head against this thing, and I finally figured out what it was. But this board had lots of issues, and I want to highlight what those issues were. The first thing that I wanted to test is that this C9 again, we had a lot of what we call AC ripple. So what AC ripple is that it was not filtering out the plus 5 volts appropriately, causing a lot of oddities in the board. So that's one thing here that needed to be resolved, is that replacing this C9. Again, if I look at my specific capacitors, as I showed a moment ago, these don't have this same amount of bulge happening, but they're still pretty old and still worth replacing. Again, not an issue at the moment, unless I find out that I'm not getting capacitance at those levels. I also want to look through and see, from the top side, all my resistor packs. I see they all look pretty well. Again, I see some different things where they've switched out, or this is an earlier board using the different ceramic resistors instead. And again, looking at my my area over here at my solenoids, looks like no one's done a lot of work. I don't see a lot of rework in the solenoid area. So all in all, it looks like it's pretty good from the top. But when we turn it up and turn it over, you'll see quite a different story. This board has been reworked. And again, some of this by me, some of this by other people, but we can see a lot of rework that's been done. So again, this is going to be one thing that tells us someone has worked this board over, either from a good perspective or a bad perspective, but that's something to keep an eye on. Now, let's go ahead and fire this board up. All right, so we see a 7. Now, that makes sense. A 7 is going to be some sort of general issue. What I found that to either be is potentially something with the reset circuit, your IRQ circuit, or even something with your ROM chips. In this case, we don't have any ROM chips. So that would pretty much tell us that's the reason why we're getting 7 on this board. But looking through it, one thing else that this board had an issue with is down here at Q52. So Q52 is a 2N3904 transistor. And I think it's important to pull out the schematics and show why Q52 is so important from a testing perspective. So I've just got some Sorcerer schematics here. You can use any System 9 schematics. It doesn't need to be Sorcerer, but I just have one laying close. So here's our logic power. This is our 1J17. And then you can see here that we have this Q52 right here, this 2N3904. And we can see that that actually goes up and helps run off the CMOS B+, and also connects down into our to our CMOS going away. In this case, this specific transistor on this board, this was broken. In fact, I think I still have it. I don't think I threw it away, but it's probably, oh, here we go. So this is actually Q52 that I just took out of the board prior to turning the video on. And you can see that it's missing a leg. So that's not going to work. It's not going to work for us. So in that case, replacing this Q52 allowed U18, which is our RAM, to actually fire up and give us a potential other issue. So what we were seeing earlier was a 1. So the RAM was not being able to be initialized properly, giving us a 1 here. But in this case, we're getting a 7 because we're missing potentially these two ROM chips. So what we'll do is let's quickly put in these ROM chips, and we'll show how that works. All right, so here we are back with board number 2. I do have 2 ROMs, EPROMs, that I have programmed myself. This is actually Space Shuttle. that I've programmed here. And again, I'm using the 27128s because, again, I've got that W12 jumper met appropriately. So I don't need this specific one from here. So let's turn it on and let's see what happens. All right, and now we're getting our 0. Again, this is telling that the logic side of the board is now working. I still need to come back and test this and make sure that my solenoids or my lamp driver, my lamp transistors and all are working appropriately. But hey, thumbs up. Board number 2, working like a champ. Okay, board number 3. So again, first thing that I notice is not only am I missing my 2 ROMs, I'm also missing a CPU here, one of the 6808s. As I take a look across the board, again, no corrosion, always good. And I'm not seeing any, I see some rework here. Looks like that someone has blown both these chips in the past. That's a pretty common thing here, where if you get a stuck-on solenoid, these chips will blow. As I look through, I don't see anything else that's relatively an issue until I start looking at my resistor pack. So here's a resistor pack up here that has obviously suffered some damage. So that's going to need to get replaced. I mean, you'll still see things like this, these connectors that are broken that need to be replaced. And all in all, just kind of dirty. But again, I'm not seeing anything from the top side of the board that's a big issue or deal that needs to be addressed. So let's look underneath the board. My eye is immediately drawn to this. It looks like they've definitely had to use some jumper wires here. This is off a transistor. Looks like right here. So someone has, looks like either this transistor got really, really warm sometime or someone did a very poor job removing it. So that's something that's been resolved. Also up here, I see a lot of flux. This is something I'm going to probably clean up. Flux is conductive. So this could be bridging some specifics. It looks like that is a 7408. So it's probably has been a buffer chip that has probably, or a logic chip that may have blown when this is blown. So something to keep an eye out there for. Over here, we just see a lot of heat. In fact, I'm seeing it looks like even some issues down here with this actually connecting appropriately. So lots of heat here on these resistors that have occurred. Also going up here, lots of heat. Has blackened the board. Again, not bad. It could mean there's something else going on the board, but that's not necessarily going to be something that we need to clean or take care of. It just means we've seen the footprint of things that have happened to this board in the past. So things to keep our eye on. As we look over the rest of the board, again, relatively clean outside of that. These are all pretty normal things. So again, it's important to note when you're buying used or untested boards that are definitely this old, you're going to have problems. And the great thing is when you buy untested, you can sometimes get a good deal on these boards, and especially how difficult it is to get these boards. System 9 boards are really rare to run across with. I just happen to run across 4 at the same time. So what we need to do first is let's get the 6808 in, let's get our ROM chips in, and then let's try firing up the board. Okay, we've got board 3. Again, we've got our 2 space shuttle ROMs that, again, I burned and have verified to know that they are correct. I've put in a replacement 6808 that I pulled from another board. And then also, just looking over the board, I look like everything else is ready to go. So let's go ahead and turn on our power. All right, we get our 0. So he shows that this code is running, that the logic side of the board, good to go. So hey, 3 for 4 so far, or actually 3 for 3. Doing well on these used untested boards. Again, I'll need to come back and fix this. But again, I just want to make sure that the board itself can boot on the bench. I can always come back and fix those small things before I actually put it in the machine and test. The last thing that I'll mention is that we do have our 6616 or 6116 chips here. These are our RAM chips that I want to replace with NVRAM. So I'm still going to come back to this board, replace this with the NVRAM in the future as well. I may not use this board today as part of Sorcerer, but I'll have this board nice and cleaned up so that when I'm ready to install this in a System 9 game in the future, I've got a board. Now we're on to board number 4. So here we go. My goodness, this board has seen, it's seen some things. It is just kind of a mess, just a little bit of everywhere. So let's start at the high level. Let's look at all our socketed chips. So first off, we see that definitely some rework here. Someone's replaced this 6821. Someone's replaced this U45. Over here, we're missing 6808. We've got some old, which reads comment. So I've had a couple of those in the past. So again, we've got our 2 chips here. We're not using our second ROM chip, so we need to check double W12. That's a 0 ohm resistor. That looks great. But man, look at this. Something caught on fire, and it went in a blaze. Everything is just blackened, and it's a little dirty, but I mean, I think it's just blackened. Something, I mean, you can see here we've got some 7408s. These are some buffer chips or logic gates that don't look healthy. We've got a transistor down there that doesn't look necessarily very clean or healthy around it. So this thing's got a lot of issues. Let's take a look at the bottom. Okay, so that does not look very good. So we've talked about electrical tape. It is not a great source of affixing something for a permanent basis. Someone has taken a variety of different cable wires and kind of made things work. This is kind of a hot mess. I'm not going to lie. Here, this is great. They used a jumper wire to get to another jumper wire because this jumper wire must be connecting through the board. Down here, this is, I mean, the substrate is actually burned through. So this is a board that I am going to try to power on, but I don't feel real comfortable about leaving power to it very long. So let's do this. The first thing I'm going to do is got to replace this 6808 right here, and then let's find out together if this thing even fires. I have not powered this board on yet, so this will be an interesting attempt. All right, got board number 4 hooked back up. Now let's try turning it on and see what happens. Oh, that's surprising. It fired. So again, logic side of the board, good. It's just everything else looks like a mess. So again, I've got 4 boards here that I purchased that, outside of just a little bit of work here and there, they all seem to, logically, they all fire up. So now it's going to be a point of just cleaning these up, doing some more work. We've got more diagnostics to do. We've got lamp diagnostics, we've got solenoid diagnostics to do, but for the most part, things are running. Now, before I leave this, I do want to show one other thing. So for that, let me pull out a board that I have been working on, and I want to show you something very interesting about some test ROMs that you can use when diagnosing a pinball board. One thing that I use a lot that comes in very handy is Leon's test ROM. So I've got an EEPROM here that I've burned. Leon Bohr is, I believe, the gentleman's name, who made these test ROMs. You can find these not only for System 9, but System 11, System 3 through 7s, a bunch of other various MPU boards. Now, Leon's ROM does something very interesting. When I turn the board on, you'll see the 7 and 0 start to flash back and forth. So one thing he does, he's got a couple of different functions in here while using this ROM to test. You can not only, the main thing that you're here to test is also some of the PIAs. So all you'll need to do if you want to test PIAs, instead of using our little Neo lock that we built the other day, is you can actually go in here. Oh, here's that Neo lock that we just built earlier. But you can also go in here and actually test your PIEs in the board. So that way, if you have a broken trace, or maybe you have something else going on, you can test that appropriately. I'll just back over here. But in order to do that, you need either some sort of oscilloscope, or in this case, a logic probe. Now, this is the logic probe that I have. It's an Elenco probe. You can buy these on Amazon. I'll put a link down in the description. But what this logic probe does is actually test and show you if something is pulled high or pulled low on a specific trace that you're working on. In this case, what I want to do is I've got my 2 alligator clips. I'm going to hook them right up down here to the same 1J17. So one for ground, one for 5 volts. And now my logic probe is on. Now what I can do is I can go to any type of, let's say one of our specific there, and you can see that now it's blinking high and low. So now you can actually test all your pins. You may find a couple pins that aren't working. Sometimes as you read Leon's documentation, that's normal, depending on jumper settings and specifically what pin you're on. But you'll find that most of the time, you'll have this kind of it's high. On the address and data line, you'll find that you'll get the appropriate blinking. So you now can test if you have all your PIAs, you don't want to pull these out of the board, they're not socketed, you can use your Leon's test ROM to do that. One of the other interesting things is he does have a memory test or a RAM test. You can actually hit the switch. This is switch 1 way over here. You'll see that it'll stay just real quickly on either 7 or 0. And then if it starts flashing again, that means the RAM test was good. If it stays stuck on, that means the RAM is bad or something is not able to read and write successfully to RAM. In this case, by doing this test, it just very quickly, without about a second, stays on the one number and then continues to go. Now we already saw this board powered on appropriately and that we have this running as well. If for some reason this was not blinking, that means that there's something that's causing the CPU not to run the code on Leon's test ROM. So then you've got a variety of different issues that you can look at for doing that. But again, just by going here, I can test now all my address and data lines across my different PIAs to make sure that everything is working appropriately. So Leon's test ROM, great utility ROM to have. Another great thing to use in other boards when it comes to testing. But now we've got all these boards resolving. We now have zeros across all 4 boards. The next thing we need to do is now check and test the solenoids and the lamps. And I'll do that in an upcoming future video. So with that, we've got our 4 boards working tonight. I'm going to call it a break. I'm going to go find something else to do with the rest of the evening. So with that, that's going to be all for Pinball Workshop today. If you like these videos, please let me know in the comments below. If there's something specific that you'd like to see, let me know as well. I will also have a full video, Tech and Tools video, coming out about logic probes and how to use them. And I also have one coming with an oscilloscope video. So if you're more interested in board type of work, we'll be getting deep into that in a future video. All right. Thanks, everyone.